Okay, here is question 20 of exercise 12.6 on polynomials. Okay, this one's a long one. I've worked out the solution, so I'm going to talk you through it. Of course, if you want more details, see me in class. We are asked to solve 6x to the 4 plus 5x cubed minus 24x squared minus 15x plus 18 equals 0 if the sum of two of its roots is 0. Now, there are going to be 4 roots altogether because it's a quartic. Okay, so we're going to let A, B, C and D be the roots. All right, now 2 of the roots are 0, and so I've chosen that C plus D is equal to 0. Okay, the sum of 2 of the roots are 0, so C plus D equals 0. All right, and the first thing you're going to do is write down the sum of the roots. Okay, and the sum of the roots is minus B over A, minus 5 over 6, written that down. C plus D is equal to 0, as we've written here, so that'll be A plus B plus 0 equals minus 5 on 6. So we get equation 1. Okay, then we find the sum of the roots 2 at a time. All right, so we write down AB plus AC plus AD plus BC plus BD plus CD. Okay, that's equal to C over A. So to be minus 24 is C, A 6. So minus 24 on 6 is minus 4. All right. Now, keep in mind this little expression here that you wrote, because it's going to help you simplify along the way. All right. If you look at this expression, you'll be able to factorise pairs, okay, so that you get C plus D in brackets, and then you can eliminate some of those. All right. So you've got AB, that's there. Then you've got AC plus AD. Well, common factor of A comes out and you can write C plus D in brackets for those two terms. You could do the same with these two terms. Take the B out, common factor, and C plus D in brackets. Again, plus CD equals minus 4. C plus D equals 0, so that term goes to 0, that term goes to 0. You've got AB plus CD equals minus 4, and that is equation 2. Some of the terms 3 at a time, ABC plus ABD plus ACD plus BCD, okay, that's equal to minus D over A. All right, so minus 15 over 6. And we get 15 over 6, which is equal to 5 over 2. Again, factorise so that you can get a C and a plus D in brackets. And the first two terms, okay, allows you to do that. So AB outside of C plus D. The next two terms doesn't allow you to do that, but it allows you to take out CD out, okay, outside of A plus B. Now that's going to be useful because look at equation 1. A plus B is there and it's equal to a number, so why not? Let's substitute that in there as well. All right? So simplify as you go with what you found above. All right? And so this term will go to 0 because C plus D equals 0. And this term will be CD times minus 5 on 6, because A plus B is equal to minus 5 on 6, is equal to 5 on 2. All right, I've written that there. And that simplifies to CD equals minus 3. Another simple equation, call that 3. Product of the roots, A, B, C, D, okay, is equal to E over A. E in the expression is the constant, 18 over 6. So it would be 3. All right? So we get that ABCD is equal to 3, call that equation 4. Now, because equation 3 was CD and it's equal to minus 3, like I said, use what's above, simplify, okay, to simplify with. So CD equals minus 3, put that in here. That would be minus 3 times AB equals 3, so AB equals minus 1. Call that equation 5. Okay, now take equation 1 and make A the subject. So there's equation 1. If you make A the subject, okay, you can bring the B over, it'll be minus B minus 5 on 6. So I've written that there, that A is equal to minus B minus 5 on 6. We're going to substitute that into 5, okay, because if we substitute that into 5, we're going to get, okay, and that's what I'm doing, substituting into 5, all right, and I get a nice quadratic in terms of B to solve. That's what we're after. an expression to solve with only one unknown. All right, and using the factor method, I get that it factorises to 3b minus 2 and 2b plus 3, okay, equal to 0. When you solve that, of course, it's going to be b equals 2/3 and minus 3 on 2. All right, substitute those back into here, all right, so that you get your corresponding y values. So when b is equal to 2/3, we go a is equal to minus 2/3 minus 5 on 6, and you're going to get a is equal to minus 3 on 2. If you're substituting b equals minus 3 on 2 in the same way, you'll get a is equal to 2/3. All right? Okay, so clearly we have two roots there. Now, as we said earlier, c plus d equals 0, and equation, which equation was it? It was equation 3 that was equal to the CD is equal to minus 3. So there we have two equations with two unknowns, C and D. The C and D are the only two we have to find now. I've renamed those as equation 1 and equation 2. And solving simultaneously, which is quite easy, very simple to do, we get that D is equal to plus or minus root 3. All right, and when D is equal to plus root 3, C is equal to minus root 3. All right, so substitute root 3, positive root 3 into the above or into there. When I make C the subject, I'm going to get C equals minus root 3. When I substitute in D equals minus root 3, I get C equals plus root 3. All right, hence the x values. Okay, so the solving that equation that we had at the start, we end up with x equals plus or minus root 3, 2/3, and minus 1.5, which are these roots that we found here.